in example 4, the random variable y is distributed normally between a mean of 20 and a variance of 9. Find the value of b such that the probability of y greater than b is 0.0668. Well, if you talk about a variable y is distributed normally between a mean of 20 and the variance of 9, that means the standard deviation is the root of 9, which is a 3. We have to have that in mind. Now, we are told that when the probability of y greater than b is 0.0668, it follows that because we don't have z, we only have y, we have to have our z, because it is z that is provided in our table. That means that the probability of, we can rewrite it in such a way that z greater than b minus 20 everything over u is over the standard deviation rather is 0, is the one which is giving us 0.0668. And because we have brought in the existence of z, then we can be allowed to use the table. Let us have a pictorial representation of what we are having, because z greater than something, a certain boundary, which we don't know. Greater than something, a certain boundary, it's a very, very small area, far below 0.5. So our let's call it our b is there, because this is the area 0.0668. And because in the table we don't have the probability of z greater than, we have to have now 1 minus, we have to have now the probability of 1 minus, for us to bring in the z less than. The probability of z less than b minus 20 over 3 is 1 minus the probability of the whole of this, 0.0668. And I want to explain something here. Before we get there, it is important to note that the probability of this region plus the probability of the unshaded region is 1. The probability of the unshaded region is probability of z less than b minus 20 over 3 plus the probability of z greater than b minus 20 over 3, because this is the region less than and this is the region. All these, when you add them together, they'll give you a 1. So if you want to get this, the probability of z less than b minus 20 over 3, you have to have 1 minus the probability of this, which is here. And that is what we brought there. So 1 minus 0.0668 becomes 0.9322. 0.9322. 0.9332. Now, our business is just to go to the table on page 201 and identify which value of z gives us the probability of z is equals to z. We have to go there now. The area is 0.9332. What z corresponds that? What z corresponds that? And we can already see the z that corresponds that on page 201, 0.9332, 0.99332 is 1.5. What does this mean? This means because this is our boundary, which is represented there, that means our z is b minus 20 over 3, which is 1.5. And making b the subject of the formula, b minus 20 is equals to 1.5 times 3, which is 4.5. And b is 4.5 plus 20, which is 24.5. And that is our value of b, because the question was asking us to find the value of b, which is 24.5. All right?